To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So, my dear children, in the earlier chapters, we discussed several things regarding the levers. In the previous chapter, we focused mainly about the categories or the orders of levers. Over there, we discussed about the first order levers, second order or the second class of levers, and the third order or the third class of levers. Right over there, we discussed that these orders are actually getting created mainly because of moving of or else displacement, or else we can in simple say that change in the positions of load, effort and the fulcrum. Okay, so according to the positions of the load, fulcrum and the effort, we can clearly identify the three categories or the three classes or the three orders of levers. Okay, so now my dear children, within this chapter we'll be mainly focusing about the calculations related to levers and other kinds of machines. Okay, calculations related to levers and other kinds of simple machines. Now within these calculations, we are going to find out how these levers and other simple machines are beneficial to us. Okay, then what are the special facts that we can observe within these levers and other kinds of simple machines? Okay, so we'll be learning about these calculations and about these mathematical things related to the levers and other simple machines within this lesson part mainly. Okay, now let's head on to see the first and foremost mathematical operation or the mathematical concept regarding the levers. So here you are given with the topic, the first and foremost mathematical concept is the velocity ratio. Velocity ratio. So the velocity ratio of a lever, we are going to discuss about the velocity ratio of a lever. So here it is given. Let us consider the lever device used to high a load up. Effort is applied on the point B of this lever. Let the point B travels to point X, which is the displacement of the effort. Now here it is given, my dear children, this is the lever rod which is being firmly fixed to the point C, the fulcrum, and here you can observe the load. Now load is initially positioned to point A. Let's imagine that is the ground level. So the lever is positioned to A at the load, right? Then my dear children, at the effort, right, the effort is being applied to point B, and by the application of that particular effort, we are moving the lever arm downward to this X point. So when doing that, the lever arm travels down and the point A travels, which is the load, is going to travel towards the point Y, from A to Y. So the load is traveling from A to Y over here, while the effort is moving from B to X over here. Okay. So as usual, you can identify the effort arm, the distance between the fulcrum and the effort. Then you can identify the load arm, distance between fulcrum and the load. Okay, right. So here you can identify these things within the diagram. So within the explanation given here also, right, by reading out that thing also, you can get the idea what kind of a thing is going to happen within this lever. Right then, so let the point B travels to the point X at the effort, which is the displacement of the effort. So this special thing or this displacement which is given out by, right, the displacement which is given out by the effort over here is referred to as the displacement of the effort. The displacement of the effort, my dear children. Displacement of the effort, right? Then sometimes load is lifted, right? Sometimes load is lifted from A to Y. So my dear children, here it is given as sometimes, but it should be changed to as same time, right? Not sometime, it should be same time. So in your textbook also there's a small bit of an error. So I'll recorrect it. In here, this one should be same time, okay? Same time. Right, same time. So same time load is lifted from A to Y. So at the same time, when I'm going to push the point B to point X by giving out a certain effort, at the same time, the load is getting lifted from point A to point Y. That's how the lever works, right? So, same time, load is lifted from A to Y. Therefore, AY is the displacement of the load. So, the second concept, the displacement of the load. AY is the displacement of the load. So, this particular, in simple, my dear children, this particular length is called displacement of effort. Displacement means, my dear children, that is the shortest length between 2 points. Shortest length between 2 points. Always it is a straight line. So you'll be learning about distance displacement in brief when you go further with the grades. I mean, in grade 10 you'll be learning about these things. Okay, just to now, displacement means actually it is also a distance, but however, this is the distance between the simplest distance or the shortest distance between 2 points. Okay, that means always we have to measure this distance by using a straight line. So displacement of effort means the straight line distance which the effort has traveled during the operation of the lever. Okay, in here the Bx. Now over here you can observe, in here you can observe Ay. This is the, right, this is the displacement of load. Right, displacement of load. This particular height is the, or the displacement is the displacement of the load. This particular height or this particular length is the displacement of the effort. So I'll mark here AY. So I hope that you got the idea about the displacement of the effort and the displacement of the load, right? Okay. Then velocity ratio of a machine is the ratio of the displacement of effort to the displacement of load during the same time. So velocity ratio means, my dear children, it is the ratio between displacement of the effort and the displacement of the load. Ratio means a division of two numbers, no? Right? Ratio means, in simple, we can say that it is a division of two numbers. So to find out a ratio, you just take one value and divide it by the second value. Okay? So velocity ratio can be defined displacement of the effort division displacement of the load. So these two are referring to a ratio, a certain ratio. Ratio means a division. So my dear children, we can clearly find out, okay, or else we can, like without any problem we can find out the velocity ratio. So velocity ratio is quite simple. What you have to do, you just take the effort, the displacement traveled by the effort, and divide it by the displacement of the load. So this is how to find out the velocity ratio. The velocity ratio, okay? Displacement traveled by the effort division the displacement traveled by the load, velocity ratio of a lever. Right then, so it's very simple. In here you can define it as like this. So displacement traveled by the effort is equal to here Bx, and the displacement traveled by the load is equal to Ay. So this is the velocity ratio, Bx over Ay, right? Bx over Ay. This is the velocity ratio, right? So as it is a ratio, my dear children, now let's imagine that Bx is equal to 15 centimeters. And Ay is equal to let's say, 5 centimeters. So in here, first and foremost, the two units are getting cancelled each other. Upon a division, you know that the two units are getting cancelled. Then, my dear children, we can get a certain value. For that value, there are no any units. Just 3. That is, what do you mean by a ratio in here? Within a ratio, or in a ratio, my dear children, we won't be able to observe units. Okay? So always remember, within a ratio, there are no any units. Always remember, ratio means there are no any units at all. So in here, when you divide displacement of the effort by the displacement of the load, you can get the answer as just 3. This is just an imagination, my dear children. When we are moving with the lesson part and when you are doing some calculations, you will be, all right, will be getting, these kinds of answers. Okay, but before that, let me explain about the units related to the velocity ratio. So remember, as it is a ratio, there are no any certain units. We will be just receiving a certain number, that's it. Okay, right then. So I'll erase this thing because it's just a imagination. So I'll erase. Okay, so this is the velocity ratio then. Always remember, the displacement traveled by the effort division displacement traveled by the load is equal to the velocity ratio. In simple, in here, B has traveled to the point X, which is the effort. So Bx division A has traveled to point Y, which is the load, Bx over Ay. This is the, right, this is the velocity ratio then. Okay. So according to the mathematics, same value can be obtained by dividing the length of effort arm by the length of the load arm. Larger the velocity ratio of a machine, smaller the effort that should be applied on it. So according to mathematics, my dear children, same value can be obtained by dividing the length of effort arm by the length of load arm. So that means velocity ratio is also getting equal to effort arm division the load arm. Okay. Earlier we discussed that velocity. Now let me take you to that thing. See, earlier velocity ratio equal displacement given out by the effort division the displacement given out by the load, right? Okay, this is the first and foremost one. All right, but however, according to mathematics, they are saying that it is also getting equal to effort arm. See, it is also the same value can be obtained by dividing the length of effort arm, dividing the length of effort arm by the load arm. Means that, my dear children, this velocity ratio is further getting equal to effort arm division the load arm. When you divide these two also, you can find out the velocity ratio. This is according to the mathematics. So you are given with a question here. If bx is equal to 60 centimeters, that means, my dear children, here 60. If bx is equal to 60 centimeters and ay is equal to 15 centimeters in the given example, now in here ay is equal to 15 centimeters. Then what? Then you need to calculate the velocity ratio. So let's calculate. Velocity ratio equals to displacement of effort, right? Displacement of effort division the displacement of load. Okay, so displacement of effort, my dear children, this is the effort. Displacement of the effort is equal to 60 centimeters. The displacement of the load displacement is equal to 15 centimeters. So like I said, can you remember, right? Like I said in the previous slide, centimeters to centimeters is getting cancelled first and foremost. The units are getting cancelled. Then here 15 to 1, here 60 to 4. So our answer is just 4. Now we have calculated the velocity ratio, right? It's equal to 4. What is the idea of this velocity ratio? Any idea about the velocity ratio then? You'll get the idea when you go further with the lesson part. Okay, just for now, the calculation, the velocity ratio is equal to 4. Okay, right then. So, if a velocity ratio of a machine is 4, now earlier we got the answer as 4. Then theoretically, the effort should be applied to lift a load using that machine is 1/4 of the load. Now what do we mean by that, my dear children? In here, the definition of the velocity ratio is given. So that means, my dear children, now, like I said, earlier we took the answer as 4. What is the idea of that? The idea is, my dear children, if you need to lift that load which is over there at the previous question, right? So to lift that load, you just need to apply a force which is equal to 1/4 of the load. That is what do you mean by the velocity ratio. So if the velocity ratio is 6, which means you need to apply 1/6 of the load, okay, as the effort to lift that particular load. If the velocity ratio is 10, then 1/10 of the load is being applied as the effort to lift that load. See, this is what do you mean by the velocity ratio. When you take the reciprocal of that number which we received upon dividing the velocity ratio, upon finding out the velocity ratio, that value is equal to the effort which need to be applied at the other end in order to lift the load, right? So we have to take the value of the load and we need to multiply that value by that reciprocal number which is obtained from the velocity ratio. By that way, we can calculate how much is the effort needed to lift that load. This is what do you mean by the velocity ratio. So velocity ratio is giving out an idea. Once again, see, if a velocity ratio of a machine is 4, then theoretically, the effort that should be applied to lift a load using that machine is equal to 1/4. See, 1/4, which is exactly the reciprocal of the 4, right? 1/4 of the load, but there is an exception. Let's see what is that. Actually, that should be the theoretical one. In theory, if the velocity ratio is 4, right, that means, my dear children, as much as the load, like 1/4 of times of the load can be should be applied as the effort to lift that load. In very simple, let's take a simple example. If the load is 40 Newton, right? If the load is 40 Newton of a weight, then to carry that weight, okay, or to lift that weight, we just need to apply only 10 Newton as the effort. 10 Newton as the effort. That's it. 40 multiplication 1/4, 10 Newton. This is the velocity ratio. This is what the velocity ratio is going to implement within a lever. But however, my dear children, there is an exception, a small bit of an exception. Let's see what is that. So here it is given, but in practice, the effort does not decrease down that much. That means 1/4 of the load. Now, once again, they are saying that, but however, in practice, this is not going to happen. That means in our usual life, in our normal day-to-day activities, when we are applying a certain lever to lift a certain load, my dear children, okay, we won't be able to observe this kind of a velocity ratio, or else this kind of a process. I mean, like even though the velocity ratio is equal to 4 within a lever that we use in our day-to-day life, we have to apply more than 1/4 of the force which is at the load. Why is that? It's mainly because here it is given. The reason for this is the friction in the system. What is the friction? What do you mean by this friction? A new term, friction. What is friction? So, friction is a special kind of a force which is created by two contact surfaces. When two surfaces are getting contacted each other, my dear children, right? So, because of the nature of the two surfaces, some kind of a resistance force is getting created. Some kind of a resistant force is getting created within those two surfaces in order to stop their relative motion. That's why when you kick a ball, right? Let's take a football. Now you're going to kick that football. So when you're kicking that football, the football is going to travel and stop at a certain place, right? It's not going to travel till the end of the world. It's going to travel a certain distance and it's going to stop at a certain point. Now you know that, okay, when you are applying a certain force on a certain object, that object should definitely move. And in order to stop that moving object, once again you have to apply a certain force. We have identified, or we have discussed these things within our previous chapter or within our previous lesson regarding the basic concepts associated with the force. Can you remember? When we are applying a certain force, objects are moving for sure. However, to stop a moving object, we have to apply certain force. Otherwise, those things are not getting stopped. They're going to keep on moving till the end of the time, till the end of their lifetime actually. What are the examples for those things? When you take an asteroid, you know that the asteroids or the meteoroids are keep on moving. These things are keep on moving always, all the time at our space. Why is that? Because there are no any materials contained within the space to give out a certain frictional force. What force? The frictional force. Frictional force means when two surfaces are getting contacted each other, because of their nature of the surface, right? An opposite force is getting created on a certain material or to stop the relative motion of the materials. So this opposite force is the one which is referred as the friction, but in the space, my dear children, there are no any material medium. So once a certain object is going to start a motion because of application of a certain unbalanced force, that object is keep on going, keep on moving until another force is going to stop, right? Until another force is going to stop it. Till then it's moving. So those asteroids are, when those asteroids are going to collapse with a certain planet, at that time, because of the nature of the planet, or else because of the nature of the planet or the whatever the celestial object, and now at that time another resistance force is given out by the surface. So because of that, the motion of the asteroid is going to stop. However, until then it's going to move. We won't be able to stop it unless we have to apply a certain external force, right? We have to apply a certain external force to stop it. Till then, those things are moving. I'm talking about in this space. But however, within our grounds, when you apply a certain force, the object is moving. Then after moving a certain distance, the object is going to stop. It's because the contact surface is going to provide a certain resistant force for the motion of that particular object. So this particular force is referred as the frictional force. Always the frictional force is acting against the motion of an object. Friction don't like to give out a certain, friction don't like the motion of an object. Always friction tends to stop a moving object. So my dear children, in a lever, from the pivoted point, you know that the lever is moving here and there. That means on the pivoted point, on the fulcrum, the lever, body of the lever is facing a certain kind of a frictional force. Because of that, what will happen? Some amount of effort should be given extra in order to overcome that friction. Otherwise, we won't be able to move that. Okay, for a certain example, let me give out to you like this. There is a football like this. Okay, this is the ground, this is the football. Now, the frictional force, okay, let's imagine that a person is kicking this ball, right? A person is kicking. Like this, a person is kicking this ball, right? However, within the ball and the ground, there is a frictional force of 2 Newton. There is a frictional force of 2 Newton. Within the ball and the ground, there is a frictional force of 2 Newton. Which means, my dear children, when applying a certain force on this ball by this particular person, he should have to apply a force greater than 2 Newton. Otherwise, the ball will not move. If he is going to apply a certain force greater than 2 Newton only, then the ball will move, because friction is a force that inhibits the motion of the object, right? So therefore, he has to apply more than 2 Newton. So always remember, during the motions or in our motions, which is going to happen in our ground, or when two materials are getting contact with each other, my dear children, it can be any material, okay? That means it can be two gases, two liquids, two solids, liquid and a solid, solid and a gas, gas and a liquid, whatever. If two different media are in contact with each other, then my dear children, on those surfaces, a kind of a force is getting created. This force is referred to as the frictional force. Frictional force is always, right, frictional force is always inhibiting the motion of a certain, relative motion of a certain object. In simple, you have to give out a certain force greater than the frictional force in order to move a certain object if that object is contacting a certain material, contact with a certain material. Okay, right then. So in here, this person should have to apply at least 3 Newton of a force greater than 2 Newton. So when applying a force greater than, like 2 Newton, then the person can move this object to a certain different location. So always F should be greater than 2 Newton in order to move the object, or else in here the football, right? So I hope that you got the idea about the frictional force. So within a lever, my dear children, like I said, what will happen during the motion of the lever through the fulcrum, from the point or from the pivoted part or from the fulcrum, my dear children, there is a relative motion which is going to happen. That means a certain kind of a frictional force can be observed over there. So to overcome that frictional force, we have to apply more amount of force. Like in here, you won't be able to apply 1 Newton of a force to move this object. You won't be able to apply 1.5 Newton or 2 Newton of a force to move this particular football. You have to apply a force which is greater than 2 Newton to move this football, my dear children. So therefore, right, what will happen in here, right, the frictional force can be observed. So within a lever also frictional force can be observed at the point of the fulcrum. So therefore, my dear children, theoretically, if the velocity ratio is 4, then theoretically it says that the machine can be given with 1/4 of the load, right? The effort that should be given to the machine is equal to the 1/4 of the load. That is theoretical thing, but however, we have to provide even more to lift the load because of the friction created within the system. Okay, right then. So here it is given. Thus, the mechanical advantage of a machine is always less than its velocity ratio. So the mechanical advantage is always less than the velocity ratio. This is happening mainly because of the what? Because of the frictional force, the special concept that we learned newly on today, the frictional force. Okay, so the frictional force is the one which is going to give out some amount of a lesser velocity ratio. Okay, actually velocity ratio is given to the theoretical one, but however the mechanical advantage is the one which is getting reduced over here, right? Mechanical advantage is somewhat less. Theoretically the velocity ratio is one giving as a certain value, but however we won't be able to apply that amount in our normal day-to-day activities. Okay, because the friction is going to friction is behaving as a opposite force, so therefore we have to overcome the friction, and in that case some amount of greater effort should be given out. Okay, so I hope that you got the idea then, right? So when we have then the next topic given, my dear children, the next concept that we are going to talk. So within this concept we are going to talk about the work input and the work output. Work input and the work output. Okay, so first thing, previously we have studied, right, that is the velocity ratio, displacement of effort division the displacement of the load, right? Then this is the second concept, work input and the work output. Let's see. When we have to get work done from a machine, we have to work on the machine. Work done on the machine is called the work input. So work done on the machine, right? Work done on the machine is called the work input. So work input is the work done on the machine. Next one. When the work input is given to the machine, some amount of work is done by the machine also. That is known as work output. Work output. So work input is, right, work input is work done on the machine. That means, my dear children, work input is the amount of work done by the effort, right? Then when work input is given to the machine, some amount of work done is done by the machine. That is known as the work output. So in a lever, work output in simple, my dear children, that's the work which is being carried out by the load, right? How to find out the work done? What are the things that we are going to do when we are doing some works? Now, works, okay, don't think about special cases. Like when doing work, you might think that speaking is work. No, speaking. Then thinking, that is also a work. No, sleeping, that is also a work. No, don't think about those things. Think about usual works that we do. What are the usual works that we do? Running. Okay, running, that means moving from one place to another. Lifting a bag. Lifting a bag. Then pushing a table. Simple works. When running, my dear children, you have to carry your weight from one particular location to another location. You have to carry your weight, no? Weight is a force. You already know that weight is a force. So here, to carry your weight, you are applying a certain force on your body to carry your weight. It's equal to your weight. So when you are moving, when you are going to a different location, right, especially up and downwards, you are carrying your weight to a certain different location upward, which is equal to your weight. Okay, so in here, a force has been applied to move a certain object, which is you, to a different location. Okay, when pushing a table, you are pushing a table from one particular location to another. So over there also you can observe a certain displacement. I mean, in simple, a certain distance is being traveled by the table upon applying a certain force. So during the application of force, object is moving from one place to another. Okay, object is moving from one place to another. Then in the third case, lifting a bag. In that case also, you are applying a certain force which is equal to the weight of the bag, and by applying that force, you are pulling that weight upward to a certain displacement, or else to a certain distance, or to a certain length. In here also, you are doing a certain work. Each of these instances, we are applying a certain force. By the application of this force, right, by the application of this force, my dear children, you can freely move a certain object from one particular location to another. So when we are doing works, usually we are applying a certain force to move a certain object to one location to another. Specialty here is that to the direction of the force, the object is moving. So when I am pushing the table, right? To the direction of the force, the object is moving, not to the other direction, no. When I am lifting the bag upward, the object is going to move, not downward, no, right? So therefore, to the direction of the force, an object is moving when you are doing a certain work. So to find out the work done, it's very simple. You multiply the force applied by the displacement traveled during the motion. During any kind of a work, right, during any kind of a normal particular work, force is applied on the object to move that particular object to a different location. So there is a displacement traveled and there is a force which is applied. So when you get the multiplication, the product of these two factors, you can find out the work done. What is the unit of measure in work done? There are two units. Standard international unit to find out the displacement is, or to find out the distance, is meters. So one unit is force measured by Newton, multiplication distance measured by meters, Newton meters. Okay, so there is one unit called as the Newton meters. By using Newton meters, you can calculate the work done. And there is another one, right? There is another one. My dear children, when you are doing some kind of work, you know that some amount of energy is getting spent. Now, from our body, when we are doing works, we have to provide some amount of energy, or we are giving out a certain amount of energy. Some amount of energy from our body is being utilized to do that work. So therefore, I can say this thing, right, in general terms, okay? So what is that? To do works, energy is being utilized. So work done can be measured by using the energy utilized. So therefore, work done can also be measured by using the unit of energy, which is joules. So joules and Newton meters both can be used as the unit to measure work done. Work done can be simply measured by multiplication of the force applied with the displacement traveled on the object. So this is a simple thing about work done. Now once again I am coming to this one. Work done on the machine is called the work input. Work done on the machine, work input, right? That means from the effort we are giving out a certain work input, right? So the work input is very simple. Effort multiplication, the distance traveled by the effort, or the displacement of the effort. Next one, work output. So work output is, right, that is the work done by the machine, in simple, by the load. So the work output is equal to load multiplication distance traveled by the load. Very simple. Okay, so here it is given. Let us consider the lever that we mentioned above. Let the effort at B is 50 Newton and the load lifted at A is 150 Newton. You already know how to calculate the work done. When a force is acting along a certain distance, work done is the product of the force applied and the distance that the force traveled. We can calculate the work done on the lever, work input, as follows. So like I said, my dear children, during my explanation, I told you how to measure the work done. So the work input can be simply measured by using like this. So here we are going to imagine that 50 Newton is the, right, effort which is being applied and the load which is lifted at A is equal to 150. So by applying 50 Newton of an effort, we are lifting 150 of load. Right, so this is how to find out the work input, effort times the displacement of the effort, right? This is the work input, my dear children. So work input, work done on the lever, the work input is equal to effort times the displacement of the effort. Now let's calculate the work input and the work output. So you know that work input is very simple. Okay. Now the work output, the work done by the lever, work done which is work done by the lever, work done on the load, work done by the load. So work output. How to define the work output? Like this. Like this, you can define the work output. In simple terms, my dear children, what is the work output then? Simple, my dear children, it is equal to load multiplication displacement of load, right? So here, let's calculate it. So work output, let's calculate the both. First of all, work input. So effort at B is 50 Newton and the load lifted at A is 150. So the previous question, right, which is given. So I have to move in here to calculate, to find out the two instances. So here you can observe B, it has moved 60. So here A, load, right, load has traveled 15, effort has traveled 60 in centimeters. Okay, so now let's head on to the slide and we'll calculate it. Right, so let's draw the lever first. So this is the lever. So it's moving like 15 centimeters. Then this is the effort. Then it's moving like 60 centimeters. Right. So this is our lever, my dear children. Okay. Right. So let's do this thing. Work input. So work input is equal to effort multiplication displacement. So effort is equal to, here the provided effort given in here, my dear children, at B 50 Newton. Displacement given out by the effort here. Now this is the point B. Right? So displacement given 60 centimeters. Always remember, you have to apply by using meters, not by centimeters. International standard unit. 0 to 0 is getting cancelled. Here 1, here 1. So our answer is 30 Newton meters, or else 30 joules. I told you energy is being utilized to do work, so we can measure work done by using joules. So 30 joules is the work input. Now I'm going for the work output then. So I'll use a different color. Work output number 2. Work output is equal to load. Formula is given here. Work output equal load multiplication displacement of the load. Then load is equal to, here within the question it is given, na? So effort is 50, load is 150. Displacement of the load, it has moved 15 centimeters, so 15 over 100 in meters. Okay, remember 0 to 0 is getting cancelled first. 15 times 15 is equal to 225. Newton meters is the unit, division 10. So when you divide 225 by 10, you can get the answer as 22.5, right? 22.5 joules, right? 22.5 joules, or else 22.5 Newton meters. So you can get the answer as the work input 30, then the work output as 22.5 within this lever. Okay, work input and the work output. I hope that you got the idea about the two concepts clearly, right? Okay then, so the work input and the work output, right? So remember, work input is the effort multiplication displacement of the effort. Work output is the load multiplication displacement of the load. Okay, right then, so let's head on to see the next one. So here it is given, when 30 joules of work is done on the machine, only 22.5 of joules is given out from the machine. So my dear children, when we are giving 30 joules of work, right, that means when 30 joules of work is done on the machine, only 22.5 joules is resulted here, right? So only 22.5 joules of work is given out from the machine. That means, my dear children, load is going to move to a smaller distance, but however we have to move the lever downward. That means we have to apply a certain force, or else we need to apply, or we have to do a certain work somewhat greater than, okay, somewhat greater than the work which is resulted by the lever. Okay, so in here it is given, therefore the percentage of the work given out from the machine is for the work input. So the percentage of the work given out from the machine is for the work input. We can calculate it like this. How come? So percentage we can calculate like this. Work output, you divide it by the work input and multiply it by 100. Very simple, no? So to find out any kind of a percentage, you need to multiply, right, the given amount from the resulted amount. Okay, you take the given amount, you take the resulted amount, then divide the resulted amount by the given amount, then multiply it by 100 to find out the percentage. Now over there we have given 30 joules, the resulted is 22.5 only, then multiply it by 100 to find out the percentage. Okay, percentage of the work done compared to the input and output. Let's see, 0 to 0 is getting cancelled first. You can cut by 3, right? 225, you can cut it by 3 without any problem. So here 3 times 1, then here 3 times 7, then 1 is left over. For 15 there is 5. So 7.5 is the answer, right? 7.5. 7.5 into 10, we can get the answer as 75%. 75%. So we can get the percentage between input and output as 75%. Okay, which means, my dear children, when you are providing, right, when you are providing 100% of, or else when you are providing 100 joules, right, when you are providing 100 joules of work to the machine is going to produce a work of 75 joules. This is what do you mean by the percentage of the work input and output. When you are giving 100 joules of energy to the machine, the energy utilized by the machine is going to work, or it is going to utilize, or it is going to use that particular energy to give out a certain work which is equal to 75 joules. This is what do you mean by the ratio between work input and the work output, my dear children. Okay, I hope that you got the idea then. Okay, so what we calculated here is the efficiency of the machine, and it is 75%. So I have never mentioned about that percentage. Actually, the percentage that we took over there, percentage of the work input and the output, is referred to as the efficiency of the machine. Efficiency of the machine, right? The efficiency of the machine. So here the efficiency is 75%. 75% is our efficiency. So efficiency of a machine can be defined out by work output division the work input. From this one, and when you multiply it by 100, you can get the answer. Okay, so this is how to find out the efficiency. You just multiply it by 100. Actually 100 is not given, but however, usually we are representing this thing as a percentage. Okay, so this is the percentage of, or the efficiency of the machine. This is how to find out the efficiency. When you go further with this part, my dear children, you know that work output is equal to load multiplication the distance traveled by the load. Work input means that is the force or the effort that we are providing. From that effort, we are moving that particular load to a certain different location. No, so actually the work input is equal to force that we are going to apply on the effort multiplication the distance traveled by the application of that effort. Okay, distance traveled by the lever because of the application of that effort. That means, my dear children, effort multiplication distance traveled by the effort is equal to the work input. We have learned that thing earlier. Then because of doing that particular process, the load is also going to move to a certain location. The load is also going to move to a certain point. So that distance or that displacement traveled by the load is referred to as the distance traveled by the load. Then by the multiplication of load and the distance traveled by the load, you can find out the output of the work done by the machine. So work output is equal to load times the distance traveled by the load. Work input is equal to effort times the distance traveled by the effort. When you separate into two like this, you can get a certain idea in here. Load over effort times distance traveled by the load, distance traveled by the effort. Distance traveled by the load, distance traveled by the effort. Can you remember about these two? Let me take you to the previous ones once again. Not this one, not this one, but this. See, displacement of effort, displacement of load is equal to what? The velocity ratio. Velocity ratio. Displacement of the effort division displacement of the load is equal to velocity ratio. Over there. In here, right? Let's see. Distance traveled by the load, distance traveled by the effort. You can observe that is the reciprocal of the velocity ratio, right? Then, my dear children, see here, we can obtain velocity ratio by dividing, right? By dividing the distance traveled by. So, here it should be I. In textbook also there is a small bit of a change, my dear children. So, we can obtain the velocity ratio by dividing the distance traveled by the effort to the distance traveled by load. But here it says other way around. It is similar to the reciprocal of the velocity ratio. So, like I said, like I have shown you, my dear children, here this is equal to the what? This is equal to the reciprocal of the velocity ratio. You know, in here, right, in here, the load over effort means, I haven't mentioned it, but you know that load over effort means, my dear children, in the previous chapter we have learned that thing, that is equal to the mechanical advantage. It's the mechanical advantage. So, my dear children, mechanical advantage multiplication the velocity ratio means mechanical advantage over velocity ratio is equal to the efficiency. When you multiply this one by 100, you can get the percentage of the efficiency, right? Okay, so this is how to find out, right? This is how to find out the efficiency of a certain, right, of efficiency of a certain machine, right, a simple machine. So you take the mechanical advantage by dividing what by what? Mechanical advantage, see here it is equal to load over effort, mechanical advantage, load over effort. So you take the load divided by the effort, get the mechanical advantage. Then, my dear children, you take the distance traveled by the load, take the distance traveled by the effort, you divide it and get the reciprocal of the velocity ratio. Or else in simple, you can find out that ratio, that value by dividing the mechanical advantage from the velocity ratio. From that you can calculate the efficiency, right? Usually we are representing this thing as a percentage. So mechanical advantage over velocity ratio into 100. This is the efficiency of a certain, right? So efficiency of a certain machine, right? Okay, so generally efficiency of a machine is given as a percentage. So therefore efficiency is equal to usual calculation mechanical advantage division, mechanical advantage division velocity ratio multiplication 100%. This is the efficiency percentage, right? Efficiency percentage. It's very simple, right? You take the previous one, which is over here, mechanical advantage division the velocity ratio, and my dear children, you multiply it by 100, right, to find out the efficiency ratio, efficiency percentage. Okay, efficiency percentage. In simple, right, this is the efficiency. Then this is the efficiency. Or else you can get the, right, like I did in the previous case. What was that? You can get like this. What is that? You can get the work output divided by the work input, then multiply it by 100. That is also okay, no problem. Even I did that the calculation over here. See, percentage which is in here, actually the efficiency is equal to work output, work input, multiplication 100. So 22.5 joules is the work given out, work output 22.5, then input work 30 joules, then divide and get multiplied by 100, 75%. In here also you can find out the same, you can get the same answer by dividing the mechanical advantage by the velocity ratio, then multiply it by 100, okay, to find out the efficiency. Okay, this is how to find out the efficiency percentage then. So I hope that you got the idea, my dear children. Okay, right then. So a special thing given in here regarding all the machines. So following formulas can be used not only for levers but also for other machines. For each and every machine, my dear children, then you can apply this formula. What are those? Mechanical advantage is equal to load over effort into 100 if you are giving as a percentage, okay? Or else mechanical advantage load over effort, right? Velocity ratio is equal to distance traveled by the effort division distance traveled by the load. Velocity ratio is equal to distance traveled by the effort division distance traveled by the load. Then efficiency is equal to mechanical advantage over velocity ratio multiplication 100. Mechanical advantage into velocity ratio multiplication 100. Once again, we'll remind number one, my dear children, the mechanical advantage. Mechanical advantage is equal to load over effort. Then the velocity ratio. Velocity ratio is equal to distance traveled by the effort division distance traveled by the load. Okay. Then next one, number three, efficiency is equal to mechanical advantage over velocity ratio division. Mechanical advantage over velocity ratio multiplication 100%, because efficiency is usually given as a percentage, right? The three concepts, three calculations related to machines, not only for the levers but also for each and every simple machine, okay? Right, so remember out these three: mechanical advantage, load over effort, velocity ratio, distance traveled by effort division distance traveled by load. Then efficiency, mechanical advantage over velocity ratio into 100%. Right, my dear children, so I hope that you got the idea about the calculations part related to the simple machines. So always remember, for each and every machine, my dear children, we can do several calculations regarding three main key concepts. So these three key main concepts are mechanical advantage, the velocity ratio, the efficiency percentage of the machine, right? So mechanical advantage, load over effort, then velocity ratio, distance traveled by the effort division the distance traveled by the load, then finally efficiency, mechanical advantage over velocity ratio into 100. So I hope that you got the idea about the calculations related to levers and also the calculations related to each and every simple machines regarding these three key concepts. Okay, so my dear children, with that part I'm going to finish up the chapter. So within our next chapter we'll be moving on to the next main type of simple machines that we are going to study within this lesson part, which is the inclined plane. Okay, so we'll be learning about the inclined plane in our next chapter.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.